It's Benoit from NC Scale. Please welcome.
Thank you a lot and welcome here. I'm so happy to be able to speak about Nocode and to see so many people passionate by Nocode. So great to see you here. And I want to welcome on stage Cornelius and Maxi from FINN. They came from Germany, so they are here only for you, so thank you a lot. We can sit. So I just introduce quick ourselves. So we can begin by Maxi.
Yeah, hi everybody. Can you hear me? Perfect. I'm Max from Munich. Started at FINN in 2020, where we're still 30 people. Previously studying management technology and was always inspired by the intersection of business and tech. And I'm really, really happy to be here today and present a bit about how FINN uses no-code and low-code. Thank you.
And Cornelius.
Yeah, I have a pretty similar background. Hi, everyone, first. I also have a sort of business and data science background. Started at FINN pretty early in an internship and then sort of started to work full-time to work on the operational tech for the US expansion that we're doing right now.
Thank you. And me, I'm the co-founder and CEO of NC Scale, so a tool for versioning, log management, alerting, and security, but for no-code, like GitHub for no-code. I will spend what is FINN? FINN is an online car subscription service, like leasing in Germany. And it is not known in France, but it is a huge customer of Make, one of the biggest in the world. And that's why it's really interesting to have them today, because we will speak how they scale with Make, with this automation service. I'll let you maybe introduce FINN.
Yeah, so FINN is basically an online car subscription service for everybody that does not know what it is. It basically creates a digital customer journey for customers to subscribe to a car for 6 or 12 months or even flexible terms. Just as you would do on Amazon if you would buy a pair of shoes there. You can just go on a website and subscribe to a car for a specific period of time, and it gets delivered to your doorstep. It's really convenient, and after the subscription, you just hand it back to us, and we take over the whole paperwork and all the billing stuff. Yeah, so that's basically car subscriptions, and our goal is really to make mobility fun and sustainable, and also lowering the entry barrier for electric vehicles, because if you purchase a vehicle, the electric vehicle right now, it's really expensive, right? But if you get it for a subscription and for like 500, 600 euros, it's much more flat.
Yes, and in only 3 years, you made that with no code, and it was impossible with code. So that's why it will be interesting to talk about. And as you raise $900 million with no code, I want to offer you a small trophy, because we need in no code to share success with no code. So I think that you can bring back in Germany.
Thank you. Should we take? Yeah,
so,
thank you. Thank you.
So I just talk a little bit about NC Scale. So we were founded one year ago, and we raised 2.6 million in February to scale with no code. So to let no code apps be able to be at code quality level, and many dev tools are missing in no code, and so we are on the top of each tools to be able to create and to have versioning, but for no code, to have log management, to have alerting, and also security. We will have a demo tomorrow at 9, so you will be able to see it deeper. But today is more about how to use how FINN use Make at scale. So first, maybe you can introduce how what is your no-code stack, and after you can explain how you use it.
Yeah, so basically our no-code stack is bit limited, like we use Make, Airtable, Retool, and also NocodeDB, but we use it quite extensively and also reaching some technical limits sometimes. Our main use case is for internal and operational purposes. So our front-end and customer-facing website is all code-based, basically, but also refers and is connected to the Airtable NocodeDB backend. And we also deployed, like, not only in Germany but also in the US, where we launched later 2021, and where we also used like the learnings we made in Germany and made a better version of our own no-code stack there. And basically, you have to say that Finn is really in the philosophy of doing no-code everywhere, and it's one of our core principles to really avoid inefficiencies, avoid manual effort, and really automate everything that we can. So that's also what you can see here on the figures. It's quite intense what we do with Make, how many scenarios we have, how many executions per day we have, and really everybody is enabled at Finn to use no code the way he wants to and can contribute to the organization. So we give every new joiner direct instant access to all the no code tools we have.
And maybe just what is the size of your no-code team developers?
The size
Yeah.
of our no-code developers, yeah, it's basically infinite because it's the number of employees we have, right? So everybody is working on that. If new interns, they're joining, they use no-code. Even our engineers sometimes in the backend, they use no-code tools. So everybody uses no-code.
Great, thank you.
Exactly. So just to give you a bit of background around the industry that Finn is working in, we've just displayed here roughly the timeline of the car life cycle and the customer interactions, and also the different service providers we need to integrate into our entire technology platform, because the automotive industry is very, very rusty, very ancient, and has not changed for a long time, right? The customer process right now is still the same. You go to a dealer, you buy a car, whatever. It's the same as it has been 50 years ago. So what you can see here is the life cycle of a car. So we order the car, mostly at the OEM, mostly new cars. We put it on the website. We price our cars. We make it available on the website for customers to subscribe through our web applications and app products. And as soon as a customer subscribes, the handover date is basically set. So the car, in the meantime, arrives at one of our facilities, which we call compounds, like big locations where cars are stored. And then a driver takes over the delivery to the customer, and it's handed over to the customer, who then keeps it for 6 to 12 months or flexible terms. And then after the subscription, the car is returned by also a driver. And as soon as this is done, like the car is defleeted or sold, depends on whether we purchased it or if we leased the car ourselves. And the problem here, as you can see, is that we have multiple different parties and tools and third-party service providers where we need to integrate throughout the whole life cycle, right? So there's a lot of operational complexity in our entire business, which is not really easy because it's very asset heavy. It's very customer facing. Everything that we do, like if a handover is delayed, like customer will be angry. So there are many crucial touch points that we need to keep, and also where we have a lot of basically tools integrated. And one of the examples that I want to mention here is, for example, for the OEMs. Some of the OEMs in our industry, they still send invoices via physical mail, right? They don't know how to send an invoice via email. Or for example, our car registration providers, they don't know what an API is. So that's the kind of environment we're working in, and it's very, very hard to get into that ancient environment with new processes, with a disruptive business model. This is why especially no-code helped us really to get into this like a bulldozer and develop new processes. And this is also where Make helped us a lot, because we were connecting all those tools together. We were able to create a digital customer journey along the entire life cycle with a lot of automations, because like we were controlling processes, right? We were not controlling some physical product. We were really controlling the entire life cycle of a car, and are still controlling this. And it makes us very yeah, it's very comfortable with Make to control all these APIs, interact with them, and connect with other tools and parties. And especially you can apply all logics in there. You can do if loops. You can create webhooks to be called by other scenarios, as also Cornelius will show. That's his passion. And like a lot of cool features that you can have in Make. And yeah, that's basically also one of the reasons why we use no-code in general, because it makes everything fast, right? You have quicker iteration cycles, you gain a lot of efficiency because you don't need two people aligning on the process while the one defines the process from a business perspective and the other one builds the process. So you basically avoid cost, you have a lean organization, it's very quick, and as a startup you're really like avoiding inefficiencies, avoiding cost, especially if you're like in this asset-heavy environment, and you really try to be as quick as possible, and also building the MVP because investors don't trust you if you don't get it done right. So that's the main issue, and that's why we use it.
And further, I think it is really important to notice that you don't use no-code because it is cheap, but it is but because it's fast, and that's the main parameter. And maybe in this room, many use no-code only for MVPs, for tests, but not because it is speed. And the cost is sometimes the main parameter of using no-code, but here not at all. So it is a great example that only no-code can do that to be at this speed.
Yeah, definitely, 100% agree. Right, Cornelius, you too. And I was really happy that our co-founders or our founders of the company came up with this idea to implement no-code right at the beginning and push everybody to use it because it makes everything much easier and faster. Yeah. Exactly, but it was not always the best that we did. So I displayed here a bit how we developed over time. We grew quite constantly over the last couple of years, and we encountered some issues that were mainly based on the mindsets that we have because of being a startup, right? Because of a startup, you're restricted, you're new, you need to grow, you need to scale, you need to save costs and whatever. So this brings up certain mindsets that, for example, you don't control single objects, but you have to control like the entire process, because a process always contains then several objects, so you need to scale and keep that in mind. And that was also one of the first issues that we encountered. So when we were just having like 10 cars or 50 cars, we were already using no-code, right? And if you already use no-code, you see that it makes a difference if there's one bug affecting one car or one bug affecting 50 cars. So that's why we were really aware that we need a proper alerting and monitoring system to keep control over everything that we do in our processes. And the next big thing that we encountered was that because everybody is a contributor, like we use no-code everywhere and everybody is encouraged to use it, we encountered like an anarchy when releasing new features or when people are working directly in the data layer. It gets really cluttered if a lot of people work on the same project. So we had many production impacts with no code also, but I mean that's one of our philosophies also is don't be afraid of breaking, right? So you have to iterate, and if you break, you learn. It's the most important thing that you learn.
It's always easier to ask for forgiveness than for permission.
Yeah, exactly.
And maybe what was your best issue that you had in no code?
So one of the biggest issues in no-code we had with production impact was basically one of our team members filtering an Airtable view, which was directly connected to the website, and then the website was completely empty and no cars on there. Yeah, that was
because there isn't development version for Airtable. So it's just a perfect use case that no-code sometimes miss some developers' things, like development version.
Exactly. Until today, we don't have like proper Airtable staging environments or something. Yeah, that's really crazy. Yeah, but it was a big problem. And yeah, maybe one of the next problems we encountered was also documentation, because everybody is contributing. and knowledge is expiring very quickly, you're really hesitant to document anything. So you don't see the need in the beginning. And that becomes a problem later on because it gets increasingly difficult for new starters to understand workflows, to understand automations, to understand the tools, and to understand the knowledge you have about tools, right? So nothing is documented, and we're starting that right now. We're in the process of documenting more and more using Miro, using Confluence, whatever, just to keep up with the knowledge and don't let it be islands, right? And then the next issue that we're encountering also right now is the security problem, because previously you're not having the focus on like credentials, on safe webhooks or whatever, API keys being publicly available somewhere, right? You don't care, you just care about getting the stuff done and getting the company built. But then at a like Series B, Series C point in time, investors look more closely at it, and in the due diligence they say, hey, did you do a penetration test? And we were like, no. And that's the main issue right now.
Yeah, for sure. Thank you a lot for that. And if you have some question, you please use the app to ask your question, and I will see them, so I will be able to answer.
Cool. So thank you, Maxi. As Maxi has sort of explained, we've been very intensely using a lot of these no-code tools, and obviously made a lot of mistakes, and have brought with us some of the most practical learnings that we've gathered over the 3 years that we've been doing this. This will get somewhat technical, so bear with me, and there's quite a lot of content there, so I'll try to go quickly. This is a bit focused on Make, but the principles apply basically to any tool stack to use. And there's 4 we've brought today. And I'll go over them now quickly, and then I'll have one slide for each with like details and examples and explaining it a bit more in detail. The first one is modularity. As we've heard before from other speakers, like these low-code tools, they're essentially just visual programming. And just like in programming, the patterns that you use, they really matter for testability and scalability and being able to expand your tech stack. So try to build as modular as possible and as event-based as possible. And I'll have an example about this. The second is try to build automations that behave as much like APIs as you possibly can, because it's the easiest and cleanest way to orchestrate the network of things you're trying to build in the back end. The third one is application monitoring. Maxi has already spoken about this a little bit, but things will inevitably break, and it's very, very crucial to be effective in debugging. And we have a bunch of very practical tips that we use to monitor our tech stack to not have it be this giant black box where no one knows what's going on anymore. And then the last one is sort of a catch-all category about like practical tips for tooling and interfaces that we've learned. And one of the key things that we did wrong in the beginning is like having people work in the data layer and having no discipline in the data model, which really like was a hard thing to basically rectify afterwards. Yeah, if there are any questions, Benoit, feel free to jump in at any time. But if not, I'll start off with the first thing. This
just maybe, how do you train your new employees to these best practices?
That's a good question. I mean, this is also something that we haven't done for a long time, and now we're starting to do this more explicitly. So we have an internal academy for these low-code tools where every new employee basically gets a bunch of Confluence pages with like explanations, tutorial videos, and then exercises for people to actually go through and do and report. Then we have a rule book for every one of the tools that we use, where we sort of have the non-negotiable rules that you need to follow when you build a scenario in Make or build a table in Airtable and things like that. So we're trying to be more explicit about that, but it's definitely something that was also very like individual curiosity driven, right? If people started, they see these low-code tools, and it's also something that's very empowering to a lot of people because they start to use it and they're like, wow, there's just all these possibilities. So there wasn't actually much explicit training you had to do and force people to learn it, because everyone was super hyped that they could like have so much autonomy and make such a big impact very quickly. So modularity. One thing that's definitely very important is don't do the thing on the left. Don't build giant scenarios that try to do 10 different things with 10 different objects. Attempt to break things down into the individual pieces of logic that then trigger each other based on events, and reuse the logic wherever you can. So to make this a little bit more, like tangible, Maxi has already spoken about the life cycle of a car. So you can think of us basically needing to integrate with these partner facilities, and they need to tell us when vehicles, for instance, have arrived. And obviously, we have multiple of those facilities, so we could replicate the logic that everywhere, basically. We could build for every facility, we could build a scenario. But a better way to do it is to have one event collector for each and every one of those facilities, and then one shared handler, which basically does the same thing for the different facilities. So you can think of it, all right, car arrived at facility 1, then we have a shared handler that basically finds the car in our database, updates the location, and then triggers other consequences. And it doesn't matter if it's facility 1 or facility 10 that sends us an update. They might all send different data structures, but we format it in the same way and then pass it over to the shared handler. And if I ever need to change something about how the handler operates, I just need to change it in one place and not 10. And other consequences you could think of are, for instance, if a car has arrived on our facility, we will want to recompute the availability date that's shown on the website, because probably the car is going to be available a little earlier. So you can think of really like these scenarios being like in programming little functions that have an input and an output. And if, say, the input for an availability calculation changes, as it would if a car arrived on a facility, you recompute it. Another event that might change the availability date is the registration provider telling us that the car has been registered. So that also triggers the same scenario, which means that if I ever need to change the logic about the availability calculation, I also just need to adjust it in one place. So it makes it much, much more maintainable and extendable, right? If you need more consequences attached to events, you can just add them as new scenarios and basically connect all these scenarios with HTTP calls, which segues quite nicely into the second point, which is sort of the anatomy of a good make scenario. We found that the best way to really orchestrate this and communicate between scenarios is to build them like little APIs. So you can see here, this is a template that basically every scenario that we build follows, and it has a bunch of sort of, like a framework that you would need to follow when you build a scenario. So it starts with a webhook, because we want to build event-based. We implement some IP restrictions to make it more safe so that only internal systems can call that webhook. We also start to implement like authentication flows where you have an API key that you need to pass. You need to pass a trace ID so we know where calls are coming from and where responses are going. This is handled by a sort of a utilities header that's also added in the beginning to every scenario. And then as any good API would do, you validate the input payload. So if, say, the availability calculation works for a car ID, if you call the scenario without a car ID, it basically rejects your call and it gives you a 400 bad request. So you can basically do filters and then if else your way through the different conditions that you need to be fulfilled to even start processing anything. And this like really increases the safety of your network massively, because it's very easy to trigger a webhook accidentally, and it's very hard to debug things if you don't have the right protocols in place. So let's say you did all of that correctly, then is when like the actual logic of the scenario would start. So I don't know, you do the computation of different dates and add some offsets that you want, and if you've successfully processed it, you return a 200 to the caller. So those API, like basically we're building very, very small microservices. You might also call them nanoservices, and every automation should be like a small nanoservice that does one particular thing and tells you about the success or failure of that process. And just basically try to use as many filters and logic checks as a sort of unit test light or a logic test light, because that's something that Procode is better at, is basically validating that the behavior is actually how you expect it to be. But you can go quite a long way with these low-code tools nowadays if you use the right filters and the right patterns.
So just, I think this slide is so much important. So I think it is clearly a masterpiece, because you can apply that for all Nocode tools, not only Make. It is also the case for Bubble, for Zapier, for Make for sure, and for any other Nocode tools. So the way to just create some module and so little scenarios with this API form finally, it's really a really good practice for Nocode. And so take a picture, and I think for all your Make scenario, you can use that.
Yeah, sure. I think we actually have this template available somewhere, so I'm happy to share it, and I'm sure we'll share the slides afterwards as well.
And if you have some question, do not hesitate.
Yeah, sure. Right, this slide is somewhat malformatted on,
We have worked
on the
this.
master.
Go back just one slide.
Yeah.
Yeah, the headers. Thanks. The headers you have here are added headers that you're going to use afterward, or they are analyzing the headers that were sent in the webhook.
Yes, so both. We have a set level, like an object of headers that we add to every response that have to be there. And we also analyze the request headers to see if the trace ID was passed and if the like whatever API key we've specified is there. So we do both. I didn't include everything in this picture to not make it too big, but we would have in the actual template there are two modules, one that analyzes the headers of the call and one that creates the headers for the response.
Thanks.
When you move to that kind of decoupling and making a lot of microservices, at some point, do you have any solution to visualize all of them? To see their
That's a perfect segue to the next slide, because that's exactly on the next slide.
Thank you very much.
All right. The slide is somewhat malformatted on this presentation. I don't know what happened here, but I'll get to the visualization in a bit. But the things that we do to monitor our application there's a couple of them. One is passing the trace ID, which doesn't really show up very well on the slide, but it's basically like in Make, you can add the scenario, like an environment variable that's the scenario URL /logs/execution ID. And that basically allows you to jump directly to the execution that called something, which makes it so much faster to debug if things are going wrong. Then we have naming conventions, which basically means that every scenario is sort of named in the same way with like team ID, then the name of the scenario, what it does, and then the email of the owner. And that's cool to like find things and sort things, but it's also very, very powerful because you can use the Make API and the emails with the error logs, then parse the name of the scenario with regex. Then you have the email, you can find the Slack tag, and you can tag the person whose scenario experienced an error. And we're a very Slack-heavy organization, so the way we basically incident handle errors is through this. Like, we're basically using Make to monitor Make. If there's an error, like via regex and a scenario, it gets like turned into a Slack notification, and then the person can open the scenario directly. You can see the execution log. It might be a bit small, but that's one of those trace IDs that will take you directly to the execution that failed. You can write in the thread if it's a bigger problem, but if you've resolved it quickly, you can just check it off and move on, and everyone knows that this incident was resolved. We have a similar sort of template for business logic errors or business logic interventions that need to happen. So if a scenario runs, let's say our delivery scheduling scenario that's scheduling deliveries in an automated way, it would check that the price is within a range that we've specified. And if it's not, we would need manual approval. And these logs these like sort of messages are always formatted in the exact same way, containing execution logs, tagging the right people, and they can be resolved in Slack as well. Next thing is pretty important, capacity. Like everything in life, automation, execution time is not free. So you have to monitor like how much of the compute are you actually using. If the system is really slow, there's probably something going completely berserk in that moment. So you want to be able to quickly see an overview of how much computation you're using. And this is actually something that Make built for us. I don't know if we did it together, but it's a Datadog like dashboard that we can just open up and see the state of how much of our capacity we're using. And then the last point is a discoverability interface and a topography generator, which is what the gentleman asked about. So starting with the first one, the top one cool thing about code editors is you can string search, right? Let's say you have an API that you've built in code, and you can go in VS Code and you can see all references to variable X, right, if you want to rename it. In a low-code stack, that's pretty hard because you don't know all the things that are like touched by you changing the name of, let's say, a column in your database. So the blast radius can be pretty big, which in order to be able to manage that, we basically built an interface. It's a retool that uses the Make API, goes through the entire list of JSON blueprints, and then finds you the 10 scenarios that are relevant with the token that you're searching for. So I could say like availability date, and then it gives me all the scenarios that would be affected if I changed something. And this is pretty granular. You can also search for specific modules within Make. So I want the email module that contains that and that name, and it links you directly to the scenario. So it makes it easier to sort of manage the ever-expanding stack. And we have a topography generator, which basically just goes through the entire stack and just traces like which scenario calls which other scenario, and then you can just pass the scenario ID, and you know, all right, these 10 scenarios will be affected if I change something here, and my scenario can be called from these 10 places. And I think this is all custom built, which took effort, and it's like some of these like took pro code, and I think these are the things where it would be really valuable to have a sort of out of the box solution, because it's through like many iteration cycles through which we had to go until we arrived at this place, and there's many empty websites and like cars with only €9 prices that we had to go through to basically figure out, all right, we need this and that tooling. So yeah. That's application monitoring.
Yes, I think it's really interesting that you build by yourself many tools to manage your scaling with Make, and it is exactly what we are doing at T-Scale to have something simple to install. So because for sure to do that it is hard, and even for your capacity dashboard, it's a custom made by Make. So no, if you are maybe little than you, it will be hard to have that from Make. So yes, for sure. So that's why we are building log management, mapping solution, and also reporting for that.
Cool. And being mindful of the time, I'm going to try to go through this last slide pretty quickly. I'm going to take a quick sip as I've been instructed that I sound dry. All right. Very quickly, interfaces and tooling. This is more of a general catch-all category where I want to explain where we started off with, what stack, and what stack we're now using in our sort of second iteration where we started in the US. So in version 1.0, we basically had everything built on Airtable. Airtable was the database, was also the interface for many places, and it was used in Integromat or Make scenarios. And we, like the little robot is supposed to indicate APIs, like Procode APIs that we're also pulling from that place. Now, having people work in the data layer is a terrible idea because one, there are no constraints to user actions, so anybody can put any value in there, and that means you might have erroneous values in there, and more importantly, also you don't have any consequences attached to those actions. So if we say someone changed the car location manually, an automated consequence of that would be, hey, we want the availability date to be recalculated. If everyone works in the data layer, that's not possible. And then the biggest mistake we made by far was no discipline in the data model. So everyone was allowed to create tables and columns and rename things, which just inevitably created a big chaos, which is hard to maintain. And this is definitely something where data model design is not a democracy. That has to be a dictatorship, or you get complete anarchy. It's really a big mistake we made. And then the last thing, Airtable is a great tool. It's just not really built for the load that we were putting on the system, because it's limited to 5 API calls per second, which just did not work for us. So in the second version that we're doing now in the US, we made a few changes. As the base layer, we have a Postgres SQL database, which APIs can use as sort of the base layer to build Procode APIs off of for things that are very complex or processes where we want to be very sure that they're unit tested and things like that. On top of which, we have a Nocode DB, which is basically something like an Airtable-like UI experience through the browser that you can access the database with. And it exposes a REST API, which you can then use and make automations. And for every sort of business user, we're trying to build as many interfaces as possible so that we have the constraints to user actions and the automated consequences everywhere. And we're quite religious about the data model now, so we're trying to be very, very disciplined. And I will say there's a third version already being built right now, which is more pro code even still. And then we're planning to build we're building a custom Make app for our APIs so that we can sort of marry the pro code and low code environments in an even more effective way. Back over to you.
Thank you a lot for that. So I will say that just a little a sneak peek about what we did. So you saw the custom-made tool from FINN about to manage log management, for example, and that is our dashboard to see all the logs happening on each tool that you use. So from Make and from Bubble. So it is avoiding to create your own log management system. And also the alerting. And this part is to avoid to parse email, to parse things, and just to have something stable and for the long term. And parsing is not, I think, a long-term solution. It is just a good way to do that when you don't have any other solution. But to have something strong, you need to use something different. And for that, for example, it is just to be alerted the way you want, depending the scenario. So for this one scenario, you want to be alerted by text, by webhook, or by email. And for another scenario, you want to be alerted just by email because it is not important. So that's a thing to be alerted with different level of severity, finally. And then we have the version control on make. And it is, I think, your next challenge for that. It is just to understand what was the changes between two versions. And on make, the only way to do that is to restore the previous version of the blueprint. And here, with NC-Scale, you can just push the differences in our tool. And you can see there in red the parameter of this module was changed, and so you can document and see the real differences between each version. So it will help to maintain all the scenario. I have some question about that and about FINN, and we can answer.
One moment.
Thanks. How does it go exactly for the modification approval? And do you have some kind of authority checking what's done or double code review or whatever?
For NC-Scale, right?
Within FINN. How do you manage to have 3,000 people allowed to touch scenarios? Or maybe they're not allowed to touch them all.
Do you want to take that?
They are, and there's no approval flow currently. So if somebody changes scenario, deletes a module, whatever, it's gone. So we have no clear possibility to go back or to control the version. So it's really a mess, basically.
The way you solve that is basically try to hire very smart people who wouldn't do that. But even very smart people can make very stupid mistakes, especially if you don't know all the consequences. So it would be very nice if there was a way for you to protect a scenario as sort of being key, and you can't make changes to it without it going through an approval process. So yeah, that's definitely something that should be there.
Thank you. Anyone else? Maybe I don't see.
And to continue on this question, it is to talk about the CI/CD, but for Nocode. And today, CI/CD is only for ProCode. What is a CI/CD? Just a way, a list of action before pushing live. And in Nocode, it is live. As soon as you save, it is live. And there isn't process for that. So I hope that Nocode tools will be able to help us to create some staging development version, and also to create some action before deploying, like QA testing, like asking to manager to check if something is wrong, and also to check the security if there is some mistakes. So we are building first the version control with NC-Scale, but we want to be just after that with the CI/CD. And maybe the first thing that we can do in the CI/CD is just to inform all your team that something changed. And today you will need to manually go to Slack and say, "Oh, I just updated this column in the database," and nobody is aware if you don't do that manually. So it's really a pain.
And chapeau to Retool. They solved that already for the enterprise version that we are using. They connected it to GitLab, and we can create merge requests and control every change that is done. So that's pretty cool.
Thank you a lot. And we have some free poster with meme with Nocode and in your stand with code and Nocode that are great together. And we are hiring also customer success and business developer, and also maybe no coders for FINN. So do not hesitate to join us. Thank you a lot.